Okay. All right, folks. Well, thanks for joining us tonight, and I appreciate you guys coming out as we take this opportunity to share some of the results of the Watershed Snapshot Day events that we've been holding in the Allegheny National Forest over the past couple of years. So we're just going to provide a little bit of background on the event and generally how it works and kind of what we've done over the past few years in engaging volunteers and partners to expand our capacity for water quality data collection in the forest. And then we're going to share some of the actual data results of that sampling and monitoring. My name is Jake Lemon. I'm the Eastern Angler Science Coordinator for Trout Unlimited, and I manage a variety of citizen science projects throughout our eastern region, which includes the Midwest and Appalachia and the Northeast. We'll also be joined by Chuck Keyports, the forest hydrologist for the Allegheny National Forest, who will be sharing some info on some of the metals analysis that we've done and some the salts specifically related to acid deposition, a little bit about oil and gas as well, and also providing some of the background on the Allegheny National Forest and the water quality issues there. And then Josh Woda, a graduate researcher at Penn State University, will be sharing information on methane analysis that they've done in partnership with this effort and some of the results and inferences that's come out of that. So just a few housekeeping things. I've said this a few times, but everyone on the call except for the presenters are currently muted. So if you have any questions as we move through the presentation, please type them in the bottom left chat box corner. Make sure you click broadcast to all so everybody can see the question there, and we'll answer those at the end of the presentation. I expect the presentation will be about 45 to 50 minutes long, giving us 10 to 15 minutes for questions. So if you have any questions, type them in that bottom left chat box, and we'll get to them. And other than that, if you have any technical issues, you can type them in there. I'll be keeping an eye on that, and I'll try to help you out as well. So I'll say it one more time because we keep having people join, that everyone except for the presenters are currently muted, but we will have an opportunity for questions. So with that, I'll go ahead and jump into it. So just wanted to give a little bit of information on this effort in the context of TU's broader angler science strategies. For anyone who's not familiar with Trout Unlimited, we're a nationwide nonprofit organization dedicated to protecting and conserving and restoring cold water fisheries in their watersheds. We're organized into about 400 chapters throughout the country, and we also have a national organization with around 300 plus staff, of which I'm one of those staff. And we break our mission into a few different strategies, including protecting streams, reconnecting populations, so that's things like replacing culverts that are blocking fish passage, restoring streams, so like habitat and riparian restoration, and then sustaining that work through an engaged membership. And our citizen science work really plugs into every one of those strategies. We have folks doing water quality monitoring like in this program where we're collecting data to help us effectively protect streams. We have folks who are doing barrier assessments and identifying fish passage barriers as part of our reconnection strategy. We have folks that are doing things like red surveys and temperature monitoring to help us prioritize and monitor the effectiveness of our restoration work. And then citizen science is a big part of our sustained strategy by giving folks a meaningful way in which to engage with on-the-ground work that TU does. So, this project is kind of an extension of that larger effort, and just wanted to give some context there. So our Watershed Snapshot Days are an effort that we started back in fall of 2017. It's a partnership of Trout Unlimited, the U.S. Forest Service, and Penn State University. We've held 3 events so far, so fall of 17, spring of 18, and fall of 18. And basically the way these work is we engage a group of volunteers and conservation professionals from the area to all come together and basically collect as many samples as we can throughout the day. Folks will come in the morning, we'll organize them into groups, give them assigned sets of sites that they will go out and sample, usually 4 to 8 sites. We'll provide some training on the protocols, and then those groups will basically blast out throughout the forest and collect data and samples at those sites, bringing those samples back and that data back, checking it in, and then they'll go to the lab for analysis. So it basically allows us to do a lot more sampling than we could with the capacity that we have with our own staff, and it's a great way of facilitating those partnerships as well. We have another one planned on April 9th, which I'll share some information on that later. And then, Chuck and Josh are going to share more about the goals of the event. So for anyone who's not from the area that's on the webinar, the Allegheny National Forest is located in sort of the northwest part of Pennsylvania. It's the only national forest in Pennsylvania. It's over 500,000 acres, and you can see on this map here sort of generally where it's laid out. Chuck's going to provide a lot more background information, but I just want to give folks a sense of where we're talking about here. And you'll see on the map here on the right, the green dots are the sampling locations from our last snapshot day that we held, so you can see we get a pretty good distribution throughout the forest. The blue lines show naturally reproducing trout waters as designated by the Pennsylvania Fish and Boat Commission, so you have a sense of the distribution of trout streams there. Last fall we did 64 sites. We've done anywhere from about 60 to 85 sites at each of these events. We've had dozens of volunteers help out, donating over 500 hours to the effort. So it's been a really effective partnership. And speaking of partnerships, we've had some really important ones that have helped make this happen. Aside from TU and the Forest Service and Penn State, we're also working closely with the Western Pennsylvania Conservancy, Elk County, Warren County, and McKean County Conservation Districts. We've got help from Pitt Bradford University, Clarion University, and the Pennsylvania DEP. So it's really a partnership-driven effort. But with that, we want to jump into the meat of this program, and I'll hand it off to Chuck Keyports to start talking about the Allegheny National Forest and some of the results that he's seen there.
All right, great. Thanks, Jake. And thanks for joining us tonight. And I'm going to go ahead and just start the presentation talking about some of the data that the Pennsylvania DEP has collected. This map shows just an overview of all the different sites throughout Pennsylvania where they've collected macroinvertebrate data. And you can see this map, the different colors. Poor indicates poor stream quality. Yellow indicates fair stream quality, and then the blue indicates good stream quality. You can see that there's a large concentration of the blue up here right over the Allegheny National Forest. And I just wanted to point that out, that that the Allegheny National Forest and the streams up in this northern tier of Pennsylvania have some of the best water quality, but that doesn't mean they're without some of their own issues. And today we're going to talk about some of the findings from this water quality data we collected over the past three sampling efforts. And this data will all be useful for the DEP's classifications of the streams in this area. Just to give you an overview, the Allegheny National Forest is a multiple-use land management agency and a multiple-use forest. And this map kind of just gives an overview of our forest land management plan, and the areas in green and yellow are basically areas where we do active timber harvest and manage the vegetation in those areas. And then also there's areas that are indicated by blue here. That's our only major wilderness area, Hickory Creek Wilderness. And then there's also some recreation areas and also other designated areas, including 2 wild and scenic rivers, the Allegheny River and the Clarion River on the National Forest. And just to give you an overview, there's been we've got quite a rich history in the state of Pennsylvania for logging, and that has definitely played a role and impacted some of the streams. throughout the state and changed the makeup of the riparian area and the forest cover there. So I just wanted to provide you a little bit of overview of some of the history there, and also mention that there was also a lot of chemical wood industries where they would take the remaining wood that wasn't harvested for houses and that type of thing and use it for in distillate plants, as well as the hemlock bark was used for tanning. So that was another way that they made use of the resources in this area. So the Allegheny National Forest is largely a second growth forest, and when it was first established in 1923, it was known as the Allegheny National Brush Patch. So it's come a long way from then. And also another aspect of this area is that we're only 20 miles, only located 20 miles east of the first commercial oil well that was drilled in the United States. And the oil boom has been in flux here for a long time, but that has left us with a lot of legacy issues, including some abandoned oil wells and other issues related to those leaking wells that maybe weren't plugged properly or never really had good standards in the first place when they were drilled. And today we still have active oil and gas occurring on the forest. Only 93% of the forest has, or 93% of the forest is privately owned mineral rights. So these areas are, they still have to follow all state regulations, but we have little control of where they would actually be, where these wells would actually be drilled, except in that 7% where we own the mineral rights. And this just gives you an idea of the fluctuations that with the oil market, how and how that oil market relates to the number of wells that are drilled on the national forest. So it's fluctuated quite a bit in the last 40 years. So one highlight is that we don't have acid mine drainage, but unfortunately that's we do have problems with acidity in our stream water, and related to the high amounts of acid deposition and acid rain that we've received. As indicated on this map, the reddish orange colors are lower pH values of around 4 to 4.5 pH. And this map over on the right side shows that some of the geology in this area, particularly the light blue area, is geology and that is called Pottsville Formation, and it has very low buffering capacity. And the soils that were derived from this geology also have low buffering capacity. So whatever the rainwater is, that's generally the pH value that we see in our stream water. And that's led to some very low values of stream water on some of our streams on the Allegheny and throughout Pennsylvania. So this map just kind of shows an overview of looking at the different watersheds throughout the Allegheny National Forest. The watersheds that are colored in red have a high percentage, from 75 to 100% Pottsville Formation geology, while the watersheds in green have much lower percentage of Pottsville Formation. And this correlates to a better water quality as far as pH and alkalinity of the stream water. These lines here identified in yellow on this map in the red areas are all streams that the Pennsylvania DEP has classified as impaired because of acid deposition problems. And so they have some higher values of metal leaching and also lower pH. And this lower pH and leaching of aluminum into stream water can be toxic to aquatic organisms. It can result from short or long-term exposure, and aluminum toxicities as low as 0.087 to 0.2 milligrams per liter can be toxic, and it may kill the fish, or they may just migrate to stream water where the pH is higher and has less aluminum in it. And this risk of aluminum toxicity increases when the pH is below 5.2. And one thing I just saw recently is that there has been a really drastic improvement in the pH of our rainwater, and I was surprised. That's why I wanted to show you these slides that show progression of the amount of acidic rainwater that's been deposited on the East Coast. So if you keep an eye on Pennsylvania, look at right now in the 1986 map, it's colored in red, indicating that the pH of the rainwater ranged anywhere from 4 to 4.5. And as we move to 96, it gets a little lighter. Then 2006 gets a little lighter still. Then in 2016, it's quite a bit lighter now. It's almost white, and it's kind of on the greenish side. And so the pH has climbed up to a pH of the rainwater here has now gone above pH of 5, which is really a great improvement and should have really beneficial effects on some of the streams throughout the state and the east and the whole eastern United States. You can see this map shows the increase in pH from 1978 when the pH was 4, and then all the way up to 2017 when the pH reached 5.1. So that should have really beneficial effects on our stream water in this area. But there's still, from our sampling, we still see some problems, and we'll look at those results coming up on the next couple slides. So the main goals of the water quality sampling effort are to gather a baseline of water quality data throughout the ANF, determine if the waters are meeting Pennsylvania DEP water quality standards, and also monitor the impacts from current management activities as well as legacy issues. And today's talk, we're going to focus on these parameters. We're going to focus on pH, dissolved inorganic monomeric aluminum, chloride and bromide, and iron. And then other parameters I'm just going to mention right now that were not elevated above DEP water quality standards were specific conductivity, turbidity, nutrients, and sulfate. Turbidity was could be an issue at times because there are a lot of dirt and gravel roads in this area, but you really need to sample right after an intensive rain event or even during an intensive rain event. Okay, I'm getting an error right now, Jake, so hopefully this doesn't shut me out.
Chuck, I'll go ahead and move to the next slide for you.
That would be a good idea. Yeah. Let's do that. All right, did you go to the next slide?
Yeah, are you seeing it?
Shoot. That's a bummer. Okay. No, I don't see it, but I've got another. We can just keep going through this. I've got the slides right here.
Okay, I'll just move along.
Sorry about that.
Change them.
So this, I did want to mention the variability on this sampling effort. When we have, when we schedule these dates in advance, we don't know what the precipitation or the stream discharge is going to be at the day when we go out to sample. So that can be can vary from day to day. And it seems that whenever we have these events, it rains a day or two before the event, but luckily we've had pretty good weather, knock on wood, so let's hope that continues for this year. But just to give you an overview, in October of 2017, we had a very low that was the lowest discharge. It was around 3.9 at a reference USGS gauge close to the forest called 7 Mile Run. And there they have a continuous stream discharge monitoring station, and it's also a watershed that's similar to a lot of the streams that we sampled on. So it can give us a good indication of what the discharge was when we sampled, and then we can correlate that to the watershed areas of our various sites that we sampled. And so that's work that needs to be done still, but that can be beneficial for this analysis. And then April 10th, we had a discharge of 20 CFS, so it was a lot higher than the October of 2017, but to be expected in the spring of spring runoff. And then October 30th, we had an even higher discharge of 28.7 CFS, so that's even higher than the spring runoff, and that was because of a large storm event that came through about 5 days before the sampling effort. So that plays a role on the dilution of different metals and other ions when you're sampling, but it was helpful for or it did show some of the acidity problems in the streams. Okay, next slide. So this map shows an overview of the pH values we tested in the spring of 2018, and you can see the circles that are in red had the lowest values of 4.5 to 5.2, and so those would be streams where we'd expect to see higher aluminum toxicity problems. The dots that are in orange are sites that have a pH of less than 6, and I just want to mention that the Pennsylvania DEP classifies a good pH range for fish, for cold water fish, to be between pH of 6 and a pH of 9. So a lot of our samples were below that pH of 6, but the most concern areas were these ones that were below 5.2. And we'll talk about that more later. Okay, next slide, Jake. I think this one got messed up here. What slide do you have up right now, Jake?
It's a total aluminum slide.
Okay. So this just gives you an overview of the total aluminum samples. And again, we'll talk about this more on the next slide. But total aluminum is all the it gives an indicator of where aluminum toxicity could be a problem. And the dots where the circles are a larger yellow size had the highest values of aluminum in these stream waters, and that also correlated with the streams that had the most acidic waters and the lowest pH values. And you can see that again on the next slide, where when you start to look at dissolved inorganic aluminum, where we only had this, for the most part, we only had this tested in the last two sampling periods, we only had it tested when the pH was above 5.2. But the first sampling effort we tested all of them for dissolved inorganic aluminum, but this graph shows all the sites that were sampled from the last three sampling events, plotted with dissolved aluminum on the left side of the chart and pH on the x-axis. So you can see that where that red line is, that is the EPA's criteria for aquatic life, 0.087 milligrams per liter. And when any of the sites above that line exceeded that value, and so we had 5 sites that had toxic aluminum problems in the spring of 2018, and then 6 sites in the fall of 2018. And this was a surprise because generally in the fall we have more groundwater going into our streams at that time of the year. But because we had that recent storm event, we saw a pulse of acidic water going into these streams, and that caused the pH to lower dramatically. All right, next slide. The next couple slides are just a quick overview of some of the bromide and chloride values we got from our sampling events. Chloride is in blue, and orange is the bromide. And the bromide is on the right axis. The bromide values are on the right axis, and the chloride values are on the left axis. And so overall, the chloride values were very low. The DEP's water quality standard for chloride is 250 milligrams per liter, so this is very low. But if you were to look at what you would natural characteristics you would expect from stream water in this area, generally your chloride values are going to be below 5 milligrams per liter, and your bromide values are generally going to be below 0.05 milligrams per liter. But so there was a couple of sites on the far right of this graph that had higher than normal chloride and bromide values, and those are sites that also have high amounts of oil and gas, and there might be some correlation there. So further investigations need to be done to make sure that there isn't leaking pipelines that carry brine fluids. And brine fluids are typically higher in salt and can cause higher chloride and bromide values. And this, as I mentioned, the next slide, April 2018, the values overall are much lower for chloride and bromide. And this probably has a lot to do with the fact that the discharge was much higher in April of 2018 than it was in the fall of 2017. So for most of our sites on the Allegheny National Forest, the value was below 15 milligrams per liter for chloride. But we did sample 2 sites on Elk Creek. Elk County Conservation District sampled them, and those values in Elk Creek were 28.3 on the upstream site on Elk Creek, and then 65.6 milligrams per liter in Ridgeway. And we think, because this was sampled in April, it's highly likely that some road salts were going into the stream water and causing the high elevated chloride values. You see also that the bromide values are very low in Elk Creek at the same time. And then on the next slide, in the fall of 2018, we, even though, so that day was another day when we had high discharge values, and the highest chloride value was 10, and the highest bromide value was 0.9, so much lower than the fall of 2017. And the next slide shows the values of iron from our sampling event in the fall of 2017, and then plotted against it, we also have the spring sampling of 2018. And again, this large change in values from the fall of 2017 to the spring of 2018 is most likely due to dilution. And but I did want to point out that in the fall of 2017 samples, we did have 2 streams that were higher than the expected value for iron. The DEP has a water quality standard for iron of 1.5 milligrams per liter, and 2 of the streams were above that, and they were Muddy Fork and also Salmon Creek. And so that's something we want to sample those sites again during lower flows to see if we get those values again. And Muddy Fork might have something to do with the impoundment on that stream, as well as some of the other wetlands and other wetland management structures that are in that watershed. So in summary, most of the streams that we sampled on the ANF were below DEP water quality standards. This data is valuable for identifying if our management actions are resulting in changes to water quality. We need to, after some of the findings from the chloride and bromide values, we need to conduct assessments of some of the oil and gas infrastructure to kind of pinpoint if that is what's causing those elevated values or if there's something else occurring in that watershed, such as natural migration of brines into the stream water. pH and inorganic aluminum continue to be a concern on many of the streams, even with the improvements to acid deposition, and that has occurred because of the Clean Air Act. This monitoring has identified 5 new streams, almost 7.8 miles of streams, that appear to be impaired from acid deposition, and it appears that we could probably do some modeling of those sites and identify additional streams that are impaired because of acid deposition. And once we have those sites identified, we would want to work with partners, including Trout Unlimited, to identify and implement restoration opportunities that will improve the pH and alkalinity of the streams. And the next slide just shows some of the, just to point out again, these are the locations of the streams that we had identified as streams that are exceeding aluminum toxicity values and having very low pH values of less than 5.2, that the majority of these streams that are highlighted in yellow are in those watersheds where we have high percentage of pottsville formation, with the exception of the 2 that are that flow into Tionesta Creek. So these aren't on DEP's list of impaired streams, so these would be things or sites we'd want to share this data with DEP so that they can further investigate it to see if they would meet the classification for being listed as impaired. And that is the end of my section of the talk, and now Josh is going to speak about the methane sampling that has occurred on the forest.
All right, thank you very much, Chuck. So I'm going to now talk a little bit about stream methane sampling that we've been conducting in the forest. Been working with all these great volunteers in Trout Unlimited and the Forest Service as well. So sort of this idea behind stream methane is that as groundwater flows through the subsurface, you can imagine, look at the diagram on the right-hand side, as it flows to the subsurface, this groundwater may pick up contaminants such as methane, maybe as it flows by a gas well, for example. And then in the streams, we can be measuring this methane to sort of try and maybe locate any sort of contaminant sources like a leaking gas well, for example. So in surface water, methane is pretty low. You can imagine that sort of as this groundwater is underground, it's under a lot of pressure. And as that groundwater comes to the surface, that methane might bubble out. If you can imagine sort of a soda can, when it's in the can, it's under pressure, but when you open the top, the bubbles start coming out. So the methane is pretty low in streams, which means if we detect that methane, it's a pretty good indication that something's there that maybe shouldn't be there, for example. The stream methane sampling, it can be pretty quick, it's pretty inexpensive, and then it can be obviously really well done when there's a lot of volunteers helping out. So we've been doing some work with stream methane sampling across the state. You can see the map on the left-hand side has all of our stream methane samples that we've collected now over the last 3 years or so, with a lot of volunteer help and with help from Trout Unlimited. So pretty much with this map, you can see the larger the circles, the bigger the circles, the larger the methane concentration. And again, here we are in the Allegheny National Forest, where we've collected a large amount of our samples. But yeah, so in total, we've collected 1,081 samples from 533 sites. Close to 200 of these sites, I would say, were in the Allegheny National Forest. So a big chunk of our work was done there. Jake mentioned at the beginning some of these snapshot days, these larger scale sampling days that we conducted in different areas. So we've conducted 6 in total. So we've conducted 2 in north central to northeastern Pennsylvania, Cinnamahome, Pennsylvania, and Pine Creek. And then one of these days was in West Virginia, the Monongahela National Forest. And then 3 of these days we conducted in the Allegheny National Forest. What you can see is that we have mean methane concentration on the left figure, and then median methane concentration on the right figure. And you can see that these Allegheny National Forest sampling days, for the most part, have a lot higher methane concentrations, which was interesting from our standpoint, and probably one of the reasons that we spent so much time focusing on it. So here now we have sort of a zoomed-in image of our samples collected in the Allegheny National Forest. You can see here we are now zooming in on this area. You can see some of our sample locations. Again, the larger circles, the larger the methane concentrations. And of course, now sort of this green mass there are all these green dots on this figure are conventional gas wells in the forest. So there's roughly 50,000 known conventional gas wells. The area has been extensively drilled now for the last 150 years. So a lot of development. And sort of the questions we started asking ourselves was, are these high methane concentrations, could they be associated with this oil and gas activity since it's just so prevalent in the forest? Similar to Chuck's been alluding to with some of the metals and salts that he's been seeing. So we did a little bit of work. We looked, here we have mean methane concentration. So the methane, the larger the circles, the larger the methane concentration on the y-axis, and then the distance to the nearest gas well on the x-axis. And what we kind of observed initially was sort of that these largest methane concentrations, they were located relatively closer to the nearest gas well, which was interesting, but also not necessarily surprising given just how many gas wells there were in the forest. So we wanted to look a little bit deeper. We were wondering, maybe does the well age matter? Maybe are these older wells, could they be leaking more potentially? So we did the same sort of plots now, but instead now we have on the left-hand side, we looked at sort of this methane concentration, the distance to the nearest well that was drilled before 1955. And then on the right-hand side, we looked at wells that were drilled after 2005. And what, again, now we see here is that it looks like sort of our highest methane concentrations, again, this cluster where they're elevated and typically above 4, we say parts per billion to micrograms per liter. We're seeing that they are located typically closer to the oldest oil and gas wells. So that raises some questions, of course. We were wondering, are these older oil and gas wells, could they be leaking? Here we just have a picture of an old oil well where we've been doing some atmospheric sort of measurements. We had a little sort of probe. We could measure air coming out and methane coming out of the ground, and we found that there was, just in this one example, that there was methane sort of coming out all around this one gas well. So one of our questions, again, are these older wells leaking more? The data may sort of indicate that, but it's also important to recognize, sort of as Chuck has alluded to, that these areas have had a lot of oil and gas in them naturally. So some questions about, could this be coming up natural as well? In addition to looking at methane in streams, what we found too is that we were finding sort of a lot of these orange-colored discharges, orange, or you can see in the case, the top left-hand picture, this white discharge. We were finding these discharges typically around, again, these older oil and gas wells. And what we found is they may look, if you've ever seen acid mine drainage, some of them look pretty similar to that. But what we found was that when we did some sort of chemical analysis on these springs, we were finding that they were actually very oily in composition. So it looked like these springs have been impacted by oil and gas, potentially related migration. And actually, with these kind of springs, they really hadn't been described before. Anybody's been seeing them, so we've been actually calling them gas leak drainage. Maybe a byproduct of gas leakage, maybe from a gas well or from some other source, but something to be looking out for in the future, especially as we've been interested in our research. But yeah, what we're finding is that gas or oil leakage could potentially sort of mobilize the metals such as iron, which is why we're seeing a lot of this orange discoloration. If you're interested in this white color, which is a little bit mesmerizing, I would say, but that's actually bacteria that's probably, to some degree, feeding on this oil or gas as well. In addition to some of these discharges, again, we had some great tips from our volunteers about leaking abandoned wells. So Pennsylvania has along, again, this long history of development has sort of led to this abandonment of wells over time. Some estimates for the state predict that there might be 500,000 to 500,000 abandoned wells where no one knows where they are. So throughout this study, we, with some volunteers as well as the Forest Service, sort of pointed us to some wells where you can see, here's a picture of one of these wells where there's just liquids, and then there's usually a lot of gas or oil that's bubbling up out of these wells. So actually, some of our stream sampling, you can see on the picture on the left-hand side, this was a well that was upstream from one of our high methane sites. In the Western Pennsylvania Conservancy, when we started asking why the methane might be high in the stream, they told us that there was a leaking plugged well upstream from one of these sites. So we were able to come and test this and see that there was water with elevated methane coming out of here. So with that, I'll get sending things back to Jake.
All right. Well, that concludes the portion of the webinar where we're covering the results of our sampling. I'll remind you that we have some time here to take questions. If you want to type your questions in the chat box in the bottom left of your screen, please do so, and I'll read them off, and we can answer them to the best of our ability. And while folks are potentially asking some questions, I'll mention that we do have our next Watershed Snapshot Day scheduled for April 9th of this year. We are still looking for volunteers to help out with that event. It'll run roughly from 9:30 to roughly, we say 5 p.m. Some groups don't get out till 5, but some groups will get out as early as 3:30 or 4. And as usual, we'll be meeting in Sheffield. But if you're interested in helping out and you haven't registered already, please contact me. You'll see my contact information there on this slide. It'll also be on the closing slide of the presentation. And so feel free to reach out to me via email or phone if you are interested in helping out. So still not seeing any questions in the chat box. I think I'm going to try to unmute all the participants. So just know that once I click unmute, we're going to be able to hear you, or your dog barking or any kind of background noise that might be happening there. You may be, if you're not planning to speak, you may be able to mute your phone potentially. But we'll unmute people here in a second. Though I did just get one question in the chat box. It says, did you have any details for a location direction of deep horizontal drilling in the newer wells?
Hey Jay,
Josh,
I can answer that question. I'm gonna scoot back to one of these earlier slides. So it's not a great diagram, but the forest has some horizontal drilling, which I'd say it's not very common. I think actually in the entire forest, so out of those 50,000 conventional wells, there might be, I think, less than 100 or maybe even less than 50 horizontal wells. So they're not very common in the forest. I think mostly the drilling for shallower oil and gas. On this figure on the right-hand side, if you look very carefully, and you have really good eyes because it's a little small. I'm sorry about that. But these white dots are the unconventional wells. So you can see them next to maybe a couple of years. They're not very common, and I don't think we really saw that there was necessarily any higher methane or anything closer to those wells in particular. If that answers your question.
Thanks, Josh. All right, folks, I'm going to give it a try unmuting, and we'll see what happens here.
The conference has been unmuted.
All right, everybody. If there's anyone out there who would like to ask a question verbally, please do so.
Jake, Bill Eckert in Erie, can you hear me?
We hear you, Bill.
Hey, last time we did the snapshot, I noticed that we had a type of a monitoring device for pH. Found it to give different results than the test strips, and I do Minister Creek periodically, and the pH is pretty low there. But when I use the device, it was improved. It was closer to 5 or above, rather than the high 4s. Is there any chance that there would be more of those available? I'm not sure. I'm assuming they're more accurate, but I don't know for sure.
Yeah, Chuck, and I can speak to the accuracy from the last snapshot when Jake had bought those new ones, those new pH meters. We compared those to what we got, the results we got from the lab, and they were pretty much spot on for the majority of the sites we sampled. But in the previous years, we did have some problems with those handheld meters. I don't know if they were getting old or the calibration wasn't good, but we did have some variability there. But yeah, the digital meters are usually more accurate than the test strips.
Yeah, and in comparing them to the pH strips, those pH strips are really consistent. But I have found when compared to a better meter, they tend to read like just a little bit, consistently slightly less.
Right.
And so that's what I've seen that in other areas as well. So, if you are interested in getting one of those, I can send you a link to where I purchased them. I think they're about $100 a piece. And you'll also have to purchase some of the calibration solution and that sort of thing. But one thing I will mention is if you switch from pH strips to the pH meter on the sites that you're monitoring on Minister Creek, you'll want to make sure to note that well in your documentation, so that folks who are looking at the data later don't think all of a sudden there's been this like big uptick in pH.
Right.
And they know that it's probably a result of a change in methods rather than an actual water quality change.
Okay. Yeah, you send me that link, and maybe we can look at doing that after something, buy a couple of them or something like that.
Great. I see a question in the chat box from Gary. It says, is the chloride higher near unconventional wells?
No, we didn't see that in any of the results. They're pretty far apart, those unconventional wells, and there's, like Josh was saying, there's not many on the forest. I think there's only 12 pads, unconventional pads, and most of the time they're pretty far away from streams. And I can only think of a couple instances where they were close to where we were sampling, but we didn't see any relation there with the chloride and the unconventional pads.
A question on the macroinvertebrates. They do, of course, are affected by pH.
Yeah, that's one other point.
Are they sensitive to the aluminum toxicity as well?
So that's an interesting thing that you're bringing up there with macroinvertebrates. Now there's the biological index that the DEP is using, that when they do their statewide assessments is tiered towards nutrient pollution and sediment pollution. It's not really tiered towards acidity pollution. So there's certain mayflies that are tolerant of acidic conditions, and then there's other ones that are intolerant or sensitive to acidic conditions. And I think you start to lose a lot of the mayflies in some of these acidic streams, headwater streams.
Chuck, how does aluminum play into that? Do you know?
I'm not sure how the aluminum plays, but it more has. Yeah, I'm sure it has an effect on that. I don't think they've been really studied much for aluminum toxicity, but I know that they have been studied in relation to acidic waters. And so where you have the most acidic waters, you have higher aluminum, so there's some correlation there.
Okay.
What about mining, impacts of mining? Is there any significant mining now or in the past that are impacting the streams in the National Forest?
No, there's very little coal seams in the forest, and they're very small. And so there's no coal mining of any sort on the national forest.
Do you have any idea on the history as to why all of the mineral rights were given away basically that part of the purchase of the land originally?
Yeah. So when they purchased the land originally, they purchased it under the Weeks Act in 1913 to reduce flooding in Pittsburgh, and and then also there was flooding in the Allegheny too. So a lot of the Monongahela National Forest and a lot of the Allegheny National Forests were balled up to help restore the lands and reduce flooding. And when they were doing that, they were trying to purchase as much land as they could, and it was much cheaper to purchase the land without the mineral rights. So they could buy more land, and they didn't. I don't think they predicted that the oil production was going to continue as long as it did.
Other questions? Okay, hearing none. Well, thank you all for joining us tonight. We did record this presentation, and we'll be sharing a video file, or a video link rather, with everyone, so that if you want to share this or view it later, we should have the opportunity to do so. I want to thank Chuck and Josh for spending the time tonight to share some of the results of the work that a lot of you folks out there have assisted with, and thank them. And again, thank you all for your time, and I'll see many of you in April, I hope. Have a good evening.
All right. Well, thanks, Jake, for putting this call on. Really appreciate it, and thanks for all your help.
Yep. Thanks all.
Thanks, guys.